Hello everyone, I am Alp and now I'm going to talk you through about my coding algorithm Aruco for really basic algorithm. And in this algorithm, the robot just needs to see Aruco first and it will automatically do the docking position. It's beneficial for autonomous mobile robots to just go itself to the robot, to Aruco for docking position. So I just have developed a simple algorithm which is really easy to manipulate and easy to play with for the beginners, and I'm going to talk you through the steps of how I developed and which topics I have used in the system. Well, first of all, let's just talk about the basics, talk about the theory. Let's assume from the navigation goal, you just say that to your robot to go to the somewhere where you can see the Aruco, like this position, or we can just we don't need to see the Aruco robot directly. We can just rotate a bit. But whatever happens, after it sees the Aruco, it will automatically go into the simple docking Aruco algorithm. And in this algorithm, we just need these things. Robot, we have to know the theta. My robot will do this. It will turn 90. It will turn here, and then goes this x coordinate and then 90 degrees to here, 90, sorry for my paint skills, and it will go to the z axis, to the Aruco, if everything is perfect. So, what do I need? I need theta, I need to know how much should I need to turn my robot in order to being a vertical with Aruco's z axis. And I need to know the x, and I need to know the z. So this is the basic algorithm that you can probably ever gonna find out. And now I just have developed this algorithm. And I will share the code in the GitHub in probably in few days. And by the way, I'm using the RVA3 groups gazebo map because I didn't want to spend time creating my Aruco. So in here, you may see my code. It may look a little bit complicated, but from here, you guys need to understand this. We need to derive theta, x, and z. Well, we can just use some kind of complex computations like cosinus theorem or something similar like that, but we don't need it. We just need to listen fiducial transforms. Let's just listen this. Topic equal fiducial transforms. And from here, we can see this. Our camera RGB optical frame does this translational and rotational movement with our camera Aruco. So you may just think like this. Our Aruco, from our world, we can see this. And by the way, just don't mistake it with the gazebo simulator. Aries and gazebo have different X and Y coordinate for camera RGB and ODOM, so it may be a problem. Just think of it. This is my robot, and I'm just going to erase some kind of TFs. From here, you can just use the RVA3 groups, and it will be really beneficial for you. It's easy and it's nice. You can see RZ in blue, RY in green, and RRed on X. And now, from this list, we can see that translation. Translation means this. Our Z coordinates differences. How much distance between our Z coordinates to be equally parallel, equally to each other, concentric to each other. Rx similar like that, translation. And when we look at the rotational metrics, we are looking for x, y, z, and y. And I have seen some of the complex code which they use Rodriguez, but this is straightforward. Luckily, this fiducial transforms calculate this for us. The y-axis, the y rotation gives us this theta. Because if you can imagine, here we have z and x. Here, like just think of this is my y, this is my z, and this is my x. In order to turn in Z and X, you need to turn in Y rotation. This is the name of it. So our rotation should be as equal to Y in order to be vertical with this Aruco. And then we need to calculate the X diameter, X difference, and Z difference. And we can just pull out this from fiducial transform very easily. But the problem is, after some time, and you are going to see this in demo also, we are not gonna able to see the Aruco. So our robot doesn't need to always just dynamically update itself. It just needs to get the point for one time, do the rotations. After that, the last 90 from you can hear that 90, our robot will just go through. But we are all robots, and we all know that life is a little bit complicated in robotics. So if you just even if you try, you just cannot turn something 19 degrees precisely. And just for basic, if you are just going to do this rotation and translation from time, just do not. It's not working. It's just working as it wants. So I'm not just considering it, and I'm not recommending it. You just need to use the odom values from Rostopek Eco odom. It's a little bit complicated. Like I can just write probably this one is better. And one by the way just says just one time I want to edit, and it's giving the position and the orientation of the matrix of our robots. So we are just going to do this. This is my positions. What happens after I just go to a certain distance, and we are just going to calculate the how much we are going to go. This is what the code basically does. These are just imports, and from here you may see that I am using some kind of Aruco, and this Aruco just basically means for the Z push, because as I mentioned, robotics world is not that pink as it seems. Sometimes we may see our robot just looking not just directly in front of Aruco, maybe a little bit with rolling, pitch values a little bit different. So we are just going to use a PID in order to center the Aruco, and for the ease of use, I'm just using Aruco, but optimization we can just going with fiducial transforms also. And you can see just I'm subscribing, I'm publishing some kind of speeds, camera RGB, image raw. You should change whatever you are just going to use, but in TurtleBot I'm using this. Fiducial transform is our beneficial for getting this Z, X, and theta, and odom for especially the position of the robot. And this is my library I'm going to use, and I'm going to upload this code. Those are a little bit flags and initialization, but I'm going to drive it after. No need for rush. In def robot function, I'm just trying to get the position of the robot. You can see msg pose.position x just gives that the x and y and z respectively, whatever you choose. And orientation q just gives us the roll, pitch, and yaw. Well, you can just check out what is roll, pitch, and yaw from this. And in fiducial callback, it's my I will always just going to call back the fiducial, but the problem is I just want to use this value, the callback value for one time. But I cannot say this, so I'm just going to use a flag, and I'm just getting the data, and I'm just value is important, and I'm getting the rotations that y, x, and z, and then I'm just going for linear position and I'm just saying you may just think of it, if it's z, if it's on the left, it needs to turn to the right clockwise, and if it's on the right, it needs to turn anti-clockwise, counterclockwise. So this is what it does, and I'm getting the target angle, distance, first distance, and the final distance. Final distance is just z value, and self.first distance is just the y value. And in order to do this, normally this position, this theta, just gives us the value here. So I'm just saying that 19 plus x is equal to theta from our lovely little triangles. And after that, we are just going to say, just turn a little bit, turn 90 in order to be vertical with the z-axis of the Aruco. And we are just saying, if it's left, just do this. If it's on the right, just use the speed. And I tried to use the same formula, but from the right side, it didn't work. I have no idea why, but I'm gonna dig into it. And we are just using odom. Just don't use the timing. It will make a lot of problems. I'm advising you to not do it, but playground is yours. And then the first movement is the our x direction, and we will have the positions, we will have the speeds, and we are just going to through this, and we are just going to let off it, run through it, and then we are going to reach to the opposite side of the Aruco, and then we are just going to turn rotating at 90 in order to face with the Aruco, and then we are just going to go for a final push. In final push, we are just going to do this. We are just get the Aruco markers, IDs, and we say that use PID, angular, and linear version, and just go through it until you no longer see it. If you are using some kind of a complex algorithm, or you are seeing that maybe Aruco is higher on your system and camera does not see it from a certain distance, but it needs to move, you can just configure it out now for simulation purposes. We are just going Our robot can see this Aruco really well. And this is the main rotation. Well, I named my class as Odom, Rose Pirate 10, if you want, make million, I don't care. Well, not Rose Pirate shutdown, we are just going to use centering that rotate robot parallel first, and then the flag will go down, and after it finish, and then centering the first movement, flag goes down, centering rotate 19, flag goes down, and final push, flag goes down, and Raspi signal that shut down. It's a lovely command for especially the gazebo. And let's just see it, how it works. I'm just using a Python command, but you can easily just do it in this REA3 as I mentioned, and probably I was just going to fork them or just give them in a separate branch. They have made a lovely map, and our file is odom.py, and boom. Here you can see just I'm using the basic Aruco, basic coding, odom.py, and now it's just rotating. You just can change the speed, the KPU value depending on your robot needs, robot capabilities. For example, I'm using the WafflePi, the built-in TurtleBot model with just camera on it. But if you are using something else, just do it. Especially in real robots, the TurtlePi's value is really slow. It didn't even notice that it's moving. So just use it, adjust it to your basic needs. And now we are just going to turning 19. As you can see, there's a little bit delay. It's not exactly the opposite of this Aruco. But now, after the turning 90, it will go enter the last push activity. It will go through until it no longer sees Aruco. And while it goes, it will try to centerize itself with the robot. You may just sometimes people just say, especially in real world, the Aruco may just at that instant robot cannot see Aruco, and it may be a little bit problem. So I will just advise you to uh, turn off the signal shutdown command, and as you can see, it's just in the center of it, depending on your Arucos first. So thank you for listening. I'm just going to share the code and have fun and play with your robots. Thank you.